Welcome to National Geographic Young Scholar News. My name is Shelby Martin, reporting to you live from Athens, Greece, Georgia. Today we will be discussing groundbreaking, revolutionary, life-changing, super awesome experiment of the highest magnitude. Experiment research group Perfect but Confused but Still Perfect at the University of Georgia Biology Department has been toiling away day and night to solve an issue that can have a massive ecological effect. When thinking of issues of climate change, most only think of its effects on larger species such as polar bears or even themselves as humans. However, this research group has been experimenting with an animal on a much smaller level, the Daphnia. Daphnia are ant-sized, transparent creatures that are typically found in freshwater environments such as ponds and lakes. Also known as water fleas, Daphnia are known for their frenzy-like movement, similar to hungry sharks in a bloody tank, without the sharp teeth. This frenzy-like movement allows Daphnia to keep algal levels at equilibrium, as they constantly eat algae as they move. The UGA research group believes that this equilibrium is in peril because they hypothesize that the speed of their movement is directly correlated to the temperature of the water that they reside in. They believe in warmer waters, Daphnia move quickly and therefore eat algae at a faster rate. They believe that the opposite is true for colder waters. Now we are here with Sarah Robinson, one of the members of this research group. Sarah, can you please elaborate on how you conducted this experiment?
Yeah, our goal was to imitate the natural environment while making sure temperature was the only variable isolated. We set up 3 different scenarios, one where the beaker was cold at about 8 degrees Celsius. Then we had the control beaker, which was at room temperature at about 20 degrees Celsius. We had a warm beaker at about 28 degrees Celsius. We placed equal amounts of algae and Daphnia in each beaker. We then waited about 20 minutes.
Really? How many Daphnia were in each beaker?
We had about 20.
And how did you measure that change?
We measured the algal density before adding the Daphnia by counting each organism per square millimeter in a sample of the water. Then after we allow time to pass and the Daphnia eat, we took water samples again and counted the number of algal organisms per square millimeter again. Then we compared the change.
Very interesting. What kind of results did you guys expect? What did you see?
We were actually right on target with our prediction. We predicted that the change in algal density would be greater in the warm water because the Daphnia would move faster and thus eat at a faster rate. Then room temperature and then the cold water. In fact, the Daphnia and the cold water were almost completely still.
Wow, very interesting. Now, Patrick is on the field to talk about how this experiment is relative to us as a society.
Thanks, Shelby. While you may have never heard of Daphnia, these creatures are quite relevant to biology and ecology. These temperature changes in the water mimic the actual temperature of water during different seasons, so these experiments give us vital info to understanding how Daphnia survive in various seasons. Understanding their rate of feeding also helps us understand where to find them during different times of the year, what their growth patterns are, and how they affect the presence of algae in varying ecosystems. Furthermore, this information could be vital to understanding Daphnia's relatives' eating habits and how other small organisms' metabolisms work. Wow, this experiment is solving so many problems at once. Now back to you, Shelby.
What a riveting experiment. While I'm sure those of you at home have learned a lot, there's still more to it. If you or anyone you know is interested in funding the group Perfect but Confused but Still Perfect to allow them to further investigate this important cause, please contact them at 1-800-DAPHNIA. Again, this is 1-800-DAPHNIA. Catch us again tomorrow at 8/7 Central, where we will be discussing algae popsicles to beat the summer heat.